practice problem 1. Here we're going to practice using the wave speed equation. A wave on a rope has a wavelength of 2 meters and a frequency of 2 hertz. What is its wave speed? We're going to use our wave speed equation. I'm going to abbreviate wave speed as Ws is equal to WL for wavelength multiplied by frequency, FR for frequency. You'll see that this is an easy calculation, simply 2 meters times 2 hertz, times 2 hertz and this is going to equal 4 meters per second. Recall that hertz is cycles per second, or 1/seconds. So if you multiply these two together, you will get these units of meters per second, and this is my answer for practice problem number 1. Practice problem number 2. So I'm going to erase this screen here. And practice problem number 2 says, what is the wavelength of an earthquake wave if it has a speed of 5 kilometers per second and a frequency of 10 hertz? So we start off with our basic wave equation, that wave speed is equal to wavelength multiplied by frequency. We are trying to solve for wavelength, so we have to divide both sides here by frequency. And we get an expression that says wavelength is equal to wave speed divided by frequency. Now we can plug in our numbers. We get 5 kilometers per second divided by 10 hertz. This winds up being 0.5 kilometers. This is our final answer. The next problem, practice problem number 3. A student moves the end of a soft spring back and forth to make waves. The waves travel at 1.8 meters per second and have a wavelength of 1.2 meters. Find the frequency of these waves. We'll clear here again. So once again, we're starting off with the wave speed equation. Wave speed is equal to wavelength times frequency. But now we're looking for frequency, so both sides get divided by wavelength. So now my expression becomes frequency is equal to wave speed divided by wavelength. Now we can plug in our numbers. Let me move my screen here a little bit. So we have a wave speed of 1.8 meters per second, and we have a wavelength of 1.2 meters. I have my calculator open here, and I'm going to use it this time. 1.8 divided by 1.2, and my answer comes out to be, so my answer comes out to be 1.5 hertz. We have one more type of problem that I need to work with you on. I'm going to clear this screen and move on to the next slide. This is the last slide. This one talks about what is the speed of a wave in a spring which has a wavelength of 10 centimeters and a period of 0.2 seconds. So we have our wave speed equation that we've been using all along. Wave speed is equal to wavelength times frequency. The problem doesn't have any units of frequency. It says a period and a wavelength. So we know our wavelength, it's 10 centimeters, and we don't have a frequency. Nothing there is in units of hertz. Here's where you need to understand that frequency is equal to 1 over the period. So now this is going to replace FR. So my wave speed equation now becomes wave speed is equal to wavelength divided by the period. Now I can plug in my numbers. I have 10 centimeters divided by 0.2 seconds. And this is going to give me, let me use my calculator this time, 10 divided by 0.2 gives me 50. 50, and now my units are going to be centimeters per second. This concludes this video presentation.